Ooh yeah, love it. Alright, so we got 5 minutes or so to discuss why these guys multiply. That was pretty good though. You guys all just did a derivative by hand, okay? Right? Without really any issue, okay? A lot of it we got to learn how to figure out what the question's asking us. So, any written challenge on any stuff, email me, text me, figure out office hours. You can figure out a way where you can see a question and know what they want you to do. Because mechanically, you all did a really good job, right? Alright, now the reason that they crushed you, they had to do, right? Kathy and Gabriella did more algebra. Because they didn't have a number here to make it look nicer. They had to do the entire equation. But once they found the derivative, or what was the slope predictor function, some of the earlier homeworks, it was really easy for them to say, okay, what's -1, what's 0, what's 3, what's -4. So all they had to do was put it in this instead of doing that process all over again, alright? So we see why this kind of more algebra ends up paying off. That makes sense? Alright?
So we should have just found the slope predictor function and then plugged all the points.
That would have been faster. I asked you to do individual points,
Oh,
which is
okay.
kind of like what you do on the quiz a little bit. So what everyone did was totally right.
So you fix the game. So
Right. I gave you more people, so don't put that on me. Alright? Now to your, if Angela connected these in a straight, Angela, you did a great job. In a straight line, do you see how those lines are the same? Right?
Yeah.
You guys came up with the same exact equations. So now, can somebody kind of talk me through what this line, or that real line, just kidding Angela, shows based on the parabola that you drew at first? Right? So, okay, for instance, here, right, this says at all of these x values, because this is the slope, right? This tells you what the slope is. That's what we saw. You found a point, and you said the slope at -4, right alpha, is -9. So at -4, we can find, at -3, we can find what the slope is, now that we have this line. Okay? So, the y value from everywhere from -4 on until this is at around 1/2 is what? Is a negative value. Does that make sense? So what should the function be doing then if it's a negative value? If you have a negative slope, what do we know?
It goes downwards.
Yeah, that's perfect. That it's decreasing everywhere. So if I hadn't even shown you the picture of the parabola and had no idea, I just said, look, this graph right here, right Danny, gives you the slopes. You could have said, I know that it's decreasing everywhere where I have negative y values. So the same token, everywhere up here, what do we know? This is at all these x values, the parabola is increasing. Does that make sense? The derivative can tell you so unbelievably much, which is so cool. And at this point, which you see a little bit better on Todd's, I think, but if this is at 1/2, it crosses the x-axis. So what do we know? What is the slope there, right at 1/2 when it crosses? What's the y value? What's the slope? 0. Okay, so what does that mean in terms of the parabola? Where are we?
and then it's like the minimum.
Right at the minimum. Okay, so you can look at this and find the minimum based on this straight line, because that's the derivative. I know where it's 0, and I know it goes from negative slope, hits 0, and then there's a positive slope again, just like this does. Alright? And so we know right at 1/2, right when it crosses the x-axis, that's when it equals 0. Alright? That makes sense? And it's a lot of really powerful stuff, really cool stuff you can get from the derivative. Okay? And now, obviously I know you guys all could have calculated it way faster just by doing the power rules we just learned, right? You could have said, boom, 2x minus 1, without all that work, and done exactly what Todd, Kathy, and Gabriella did here, okay? And then graphed it. But if you see that at each point, what you guys did, at -4, we get a value, at 0, we get a slope, right? At 0, the slope is -1, which means it's still going down a little bit. Not as steep as up here, right? But it's still going down a little bit. Alright? Does that make sense?
Can you just explain
Sure.
one more time how you got like from point to point on the derivative function?
Okay. Well, okay. So I'm gonna use because alpha's points right here. I'm gonna use it again. So you say, okay, did all the algebra -4? You agree the slope is -9, right? The slope of the tangent line at x equals -4 is -9.
Yeah.
So we just plotted that point,
Okay.
and we did that at 4 separate points. Okay, and that ended up giving us the line we wanted, which was 2x minus 1, which you know is the derivative. So at any x value, if you find on this line, that'll give you the slope of the tangent line. Okay, so at 0, we know it's negative 1. Alright, and that's how, if you use that line, if you see where it crosses the x-axis,
Yeah.
that's when the slope is 0, and that's you can find where that minimum is. Alright? That's pretty good. That was a pretty good race. So I have to have candy for you guys as your reward?
Yeah.
Deal.
Starbucks.
I'm not taking